Hello everyone, welcome to Enthusiast Learning. Hope all of you are fine.
Today we will do Chemistry Chapter 5 States of Matter. This video is beneficial for JEE, NEET as well as KVPY. So let's begin. As we know, there are three states: solid, liquid, and gas. We will differentiate the three based on some properties. First, attractive force. Solids have larger attractive force than liquids, and then solids have almost zero. Thermal motion: solids have zero thermal motion, liquids have greater than solids, and gases have random motion. Volume: solids have fixed volume, liquids also fixed volume, and in gases it varies with temperature. Geometry: solids have a definite geometry, liquids not definite, gases not definite. Compressibility: solids have no compressibility. Liquids, they can be compressible but not very easily. Gases, yes, we can very easily compressible. Density: solids have high density, liquids have intermediate density, and gases have low density. Pressure: pressure is force exerted by the gas on the walls of the container. Pressure is isotropic, that is, it is same in all the directions. SI unit of pressure is Pascal, which is Newton per meter square. Pressure is also stated in millimeter or centimeter of mercury. Conversions: 1 atm is 760 mmHg, approx 1 bar, approx 10 raised to power 5 pascals, approx 760 torr, and approx 1 kg per centimeter cube. The pressure relative to the atmosphere is called the gauge pressure, and the pressure relative to the vacuum is called the absolute pressure. Absolute pressure is gauge pressure plus atmospheric pressure. Now question: which of the following is not a unit of pressure? A option Newton, B option bar, C option Pascal, and D option torr. As we know that bar, Pascal, and torr are units of pressure, but A option Newton is a unit of force, so the correct option is A Newton. Now we'll do measurement of pressure. First we'll discuss about barometer. Barometer is an instrument used for measurement of atmospheric pressure. It consists in inverted tube which is filled with mercury. The height of the mercury column is the measure of the atmospheric pressure. Now, as we know that volume is equals to area into height and mass is equals to volume into density, which is can be written as A into H into D. D is the density. We are talking here in respect with Hg, that is mercury. Now force, that is mass into G, which can be also written as A into H into D into G. Pressure is force upon area. Force is A into H into D into G upon area. So it is H into D into G. So pressure is H rho G. H is the height, D is the density, and G is gravitational acceleration. H can be written as pressure upon density into G. We can take pressure here as 10 raised to power 5 Pascal, density as 13.6 into 10 raised to power 3 kg per meter cube. On putting the values, we get H as 760 mm, which is very important value. We know that pressure in liquid is independent of cross-sectional area. It only and only depends on the height. Pressure at all points lying on the same horizontal level are always same. That means pressure of A is equals to pressure of B, or pressure of A minus pressure of B is 0. Now manometer. Manometer is an instrument used for measurement of pressure of gas. It consists of a U-shaped tube containing mercury. Here one limb of the tube is longer than the other, as you can see in the figure. There are two types of manometer. One is the open manometer and other is the closed manometer. In open manometer, the longer limb is open and in the closed manometer the longer limb is closed. In open manometer, if the level of Hg in the two limbs is the same, then the pressure of gas is equals to atmospheric pressure. If the level of Hg is shorter limb is higher than that of the longer limb, then the atmospheric pressure is equals to pressure of gas plus H rho g. Pressure of gas is equals to atmospheric pressure minus H rho g. Now, if the level of Hg in longer limb is higher than that of the shorter limb, pressure of gas is equals to atmospheric pressure plus H rho g. If the level of mercury in longer limb is higher than that of the shorter limb, then the pressure of gas 1 is equals to pressure of gas 2 plus H rho g. Now we'll talk about volume. Volume of a gas is nothing but the volume of the container in which it is present. That means volume of container is equals to volume of gas. Now interconversions. 1 meter cube is equals to 10 raised to power 3 decimeter cube, 10 raised to power 3 liter, 10 raised to power 6 centimeter cube, and 10 raised to power 6 milliliter, which is equals to 10 raised to power 9 millimeter cube. Now we'll move to Boyle's law. It says that for a fixed amount of gas at constant temperature, the volume of a sample of a gas varies inversely with the pressure. That means P is inversely proportional to V. That means P is equals to K by V. If we move V to the other side, then PV is equal to some constant K. So P1 V1 will be equals to P2 V2. Now graphs. Here on the y-axis there is V and on the x-axis it is 1 by P. We know that V is directly proportional to 1 by V, that means y is directly proportional to x, so it will be a straight line. Second graph, on the y-axis it is V and on the x-axis it is P. We know that V is inversely proportional with P, that means y is inversely proportional with x, so the graph will be rectangular hyperbola. In the third graph, on the y-axis it is PV and on the x-axis it is P. We know that PV is equals to constant, so there will be a straight line parallel to the x-axis. If in place of P there would be V, then also the graph would be straight line parallel to x-axis. Now question. A gas occupies a volume of 2.5 liter at 9 into 10 raised to power 5 Newton per meter square. Calculate the additional pressure required to decrease the volume of the gas to 1.5 liter, keeping the temperature constant. Here, we are given that V1 is equal to 2.5 liter, pressure 1 is equal to 9 into 10 raised to power 5 Newton per meter square, and V2 is given as 1.5 liters. And we have to find pressure 2. So applying the Boyles law, which is P1 V1 is equals to P2 V2, we get that P2 is equals to 15 into 10 raised to power 5 Newton per meter square. So the additional pressure would be 15 into 10 raised to power 5 minus 9 into 10 raised to power 5, which would be 6 into 10 raised to power 5 Newton per meter square. Now Charles' law. For a fixed amount of gas at constant pressure, the volume occupied by the gas is directly proportional to the temperature of the gas on absolute scale of temperature, which means that V is directly proportional to T, or V is equals to K into T, where K is constant. So V1 upon T1 is equals to V2 by T2. It also states that at constant pressure, the volume of a given gas increases or decreases by 1 by 273.15 of its volume at degree Celsius for every rise or fall of 1 degree in temperature, which means that Vt by V0 is equals to 1 plus T upon 273.15 into T. where N and P are constant. Also, 0 degree Celsius when the Celsius scale is equals to 273 degree Kelvin at the Kelvin or the absolute scale. Now the graphs. Here on the y-axis it is V and on the x-axis it is T in Kelvin. So here y is directly proportional to x, so there will be a straight line. In the second graph, V is on the y-axis and temperature in Celsius is on the x-axis. So there will be a straight line but a little above from the origin. Graphs between V and T at constant pressure are called isobars. We know that V is equals to K into T. So ln V is equals to ln K plus ln T. Y is equals to C plus mx. Here m is equals to 1 and here is the graph. A certain sample of gas has a volume of 0.2 liter measured at 1 atm pressure and 0 degree Celsius. At the same temperature but at 273 degrees Celsius, its volume will be A 0.4 liter, B 0.8 liter, C 27.8 liter and D 55.6 liters. As V1 upon V2 is equals to T1 upon T2, so that means that V2 is equals to T2 by T1 into V1. After putting the values, T2 is equals to 546 Kelvin, T1 is equals to 273 degree Kelvin and V1 initial volume is 0.2 liter. The final answer would be 0.4 liter. So the correct option would be A. Now Gay-Lussac's law. For a fixed amount of gas at constant volume, pressure of the gas is directly proportional to the temperature of the gas on absolute scale of temperature. That means P is directly proportional to T. That means P1 by T1 is equals to P2 by T2. Now question. A 10-liter container is filled with the gas to a pressure of 2 atm at 0 degree Celsius. At what temperature will the pressure inside the container be 2.5 atm? As we know that P1 upon T1 is equals to P2 by T2. So we get as 2 by 273 is equals to 2.5 by T2. From here T2 comes out to be 341 degree Kelvin. But the final answer would be 68 degrees Celsius as we need to find that the temperature in which the pressure inside the container will be 2.5 atm. So 341 minus 273 is 68 degrees Celsius. The final answer would be 68 degrees Celsius. Now we'll do Avogadro's law. According to this law, under the same conditions of temperature and pressure, equal volumes of all gas contains equal number of molecules. This means that V is directly proportional to N at constant temperature and pressure. 1 mole of any gas or a combination of gases occupies 22.4 liter of volume at STP. Here STP conditions means that temperature would be 298 Kelvin, pressure would be 1 bar or 10 raised to the power 5 pascals, and the volume would be 24.7 liters mole inverse. Now the ideal gas equation. Combining all the laws, we get a simple equation which can be derived as PV is equals to nRT. Very important equation. Now some values of R. R is 2 Kelvin mole inverse Kelvin inverse. R is also 8.3143 joules mole inverse Kelvin inverse. And R can also be 0.0821 liter atm mole inverse Kelvin inverse. This means P1 V1 upon T1 is equals to P2 V2 upon T2. Now a question. Calculate the number of moles of hydrogen contained in 18 liter of the gas at 27 degrees Celsius and 70 centimeter pressure. Given that R is equals to 0.0821 liter atm Kelvin inverse mole inverse. Further, if the mass of the hydrogen taken as above is found to be 1.35 grams, calculate the molecular mass of hydrogen. Here we are given V is equals to 18 liters, T is equals to 27 degrees Celsius, which is 300 degree Kelvin. P is 70 centimeter, which is 70 by 76 atm. R is 0.0821 liter atm Kelvin inverse mole inverse. Using the ideal gas equation PV is equals to nRT, we have N is equals to PV by RT. After putting the values, we get N as 0.67 moles. But we have to find the molecular mass. So, as we know that N is equals to mass by molecular mass, so molecular mass would be mass by number of moles. So, molecular mass would be 2.015 mole. Now, the relation between molecular mass and gas densities. For an ideal gas, we know that PV is equals to nRT, or we can write that PV is equals to W by mRT, where W is the given mass. Or we can also write that M into P is equals to W by V RT. We have just shift V here and M there. Or Pm is equals to dRT, where D is the density of the gas. We know that D is equals to Pm by RT, so we can write that D1 by T1. Sorry, we can write D1 into T1 is by P1 is equals to D2 into T2 by P2. This is for same gas at different temperature and pressure. For different gas at same temperature and pressure, we can write that D1 by D2 is equals to M1 by M2. Now vapor density. We know that the given mass of a gas is equals to PVm by RT, and W of H2, that is hydrogen, we can write that PV into 2 by RT, as molecular weight of hydrogen is 2. So, given mass of gas by given by mass of hydrogen is equals to m by 2, which is vapor density of a gas. It is very important. Vapor density of a gas is same at any temperature, pressure and volume. Now question. The density of a gas is 3.8 gram liter inverse at STP. Calculate its density at 27 degrees Celsius and 700 torr pressure. Now, as we know that D is equals to Pm by RT, or D1 by D2 is equals to P1 by P2 into T2 by T1. So D1 is 3.8 gram liter inverse, P1 is equals to 760 torr, temperature 1 is equals to 273 degree Kelvin. We have to find D2. And pressure 2 will be 700 torr, and temperature 2 will be 300 degree Kelvin. So we can write that 3.8 by D is equal to 760 by 700 into 300 by 273. From here we get the value of D2 as 3.185 gram liter inverse. Now, Dalton's law of partial pressure. The partial pressure of a gas in a mixture means that the pressure of the gas will exert if it occupies alone the total volume of the mixture at the same temperature. This means that P is equals to P1 plus P2 and so on. Also from here we can see that N is equal to N1 plus N2 and so on. N is PV by RT. So we can write the P1 into V by RT plus P2 into V by RT plus P3 into V by RT plus so on. Relationship between partial pressure and number of moles. First, P1 is equals to N1 by N1 plus M2 into P, which is equals to mole fraction of a gas into pressure. X1 is mole fraction of a gas, P is the total pressure, and P1 is the partial pressure. Now the partial pressure of a gas in the mixture is equals to volume by total volume into P. P is the total pressure. Now, it has been observed that gases are generally collected over water and therefore are moist. So, pressure of dry gas is equals to pressure of moist gas minus pressure of water vapor. So, the pressure exerted by water vapor is constant with water at a particular temperature, which is called the aqueous tension. It varies directly with temperature and becomes 760 mm at 100 degrees Celsius. Pressure of dry gas is equal to pressure of moist gas minus the aqueous tension. Very, very important. Now the question. The partial pressure of hydrogen in a flask containing 2 gram of hydrogen and 32 gram of SO2 is. So now let the total pressure be Pt. Pressure of hydrogen is equal to total pressure into mole fraction of hydrogen. Now mole fraction of hydrogen is equal to number of moles of hydrogen upon number of moles of hydrogen plus number of moles of SO2. From here we get the number of moles of H2 as 1 and number of moles of SO2 will be 32 by 64, which is equals to half mole. Now putting the values we get that number of moles of hydrogen is 2 by 3. So the partial pressure of hydrogen is 2 by 3 of partial pressure of total, which is equals to 2/3 of the partial pressure total.
Thank you for watching. Please subscribe the channel and like the video.